Hello students, in today's video we will learn about compound microscope. A compound microscope is used to see extremely small objects. It consists of two lenses, both are convex lenses. One is called the objective lens, the one which is near to the object is known as the objective lens. It's of small aperture and small focal length. There is an eyepiece which is placed near to the eye. It is again a convex lens with large focal length and large aperture. Now the real object is kept just beyond the focus of the objective lens. Its image will be formed on the other side. That will fall within the focus of the eyepiece. And the final image is formed on the same side as that of the eyepiece, which is called A double dash B double dash in this figure. So this first image formed A dash B dash, work as the virtual object for the eyepiece. The eyepiece behaves as a simple microscope in its working. So we will see now how is the magnification produced in a compound microscope. The magnifying power or magnification of a compound microscope is given by the formula m is equal to tan beta divided by tan alpha. What is beta here? It is the angle subtended by the image at the eye. You can see the image over here, A double dash B double dash. So the angle made over here is called beta. It is the angle subtended by the image, this image, final image at the eye. Now we have to find tan alpha also. Alpha is the angle subtended by the object at the eye. So you see this is the object. AB is the object here. So this line over here is same as AB. So what will we do is to find alpha, we will connect this to C2. So because that is the angle I makes with the object. So here we can give alpha as the angle. So tan alpha and tan beta will find out and we'll substitute in the equation. So what is tan beta from the triangle A double dash B double dash C2? So tan beta is equal to, the triangle we are taking is A double dash B double dash C2. From that you can say tan beta is opposite side A double dash B double dash divided by B double dash C2. That is tan beta. Similarly, tan alpha we will find from the triangle AB. This height is AB, so this height also will be AB. AB, or we can give a new name, B double dash, we'll call it as Q. B double dash QC2. B double dash QC2. So from there, tan alpha is equal to B double dash Q divided by B double dash C2. But what is B double dash Q? B double dash Q's height is same as AB's height. So it is AB divided by B double dash C2. So this is our second equation. So we got both tan beta and tan alpha. Now we will find what is magnification. M is equal to tan beta. Tan beta is A double dash B double dash by B double dash C2 divided by tan alpha, that is second equation, that is AB divided by B double dash C2. So when you divide, B double dash C2 get cancelled and we get A double dash B double dash divided by AB. What is A double dash B double dash is the height of the image, and what is AB is the height of the object. So we got HI by HO as the magnification equation. Now this equation you call as equation number 3, and equation number 3 if we multiply and divide by, so third equation we are multiplying and divide by A dash B dash. So what we get? M is equal to A double dash B double dash by AB, sorry, A dash B dash into A dash B dash divided by AB. Now we look at it. What is this A double dash B double dash by A dash B dash is? A double dash is the final image formed. A double dash B double dash is the final image formed. Its respective object is A dash B dash. So this first term is actually the magnification produced by the eye lens. So we can say it is ME into A dash B dash. A dash B dash is the first image formed by the objective lens and AB is its real object. So this is nothing but MO. So magnification, the total magnification we got, it is MO into ME. Now ME, I told you before itself, that is the eye lens behaves as a simple microscope. So if the image is formed at the least distance of distinct vision, that is at D, we have learned what will be M. It is 1 plus D by F. So here the magnification, the total magnification will be 1 plus D by FE, we call it, because there are two lenses with two focal lengths here. So 1 plus D by FE into MO. MO is nothing but VO by UO, because UO is its object distance. Hence, the total magnification formula is M is equal to VO divided by minus UO into 1 plus D by FE when the image is formed at the least distance of distinct vision. If the image is formed at infinity, we will write M is equal to VO divided by minus UO into just D by FE. This is for the formation of image at infinity. So these are the equations for the magnification of a compound microscope. Sometimes your question will be in terms of tube length of the microscope. What is meant by tube length of the microscope is L is equal to VO plus UE. It's positive values only you have to add. We'll see what is VO and UE is in the figure. In terms of tube length, how will we write this magnification formula? For that, what we have to do is, let us imagine this object we are sliding to F4. Okay, AB we are keeping at F4. So what will happen to the image is, so the image will also move from this FE to near to the eye lens, very close to the eye lens. So what happens is this VO, distance VO becomes almost equal to L. Under this condition, we can take our UO value as F4. We will write here UO, we will write as F4, and what is VO? Instead of VO, what we have is L. VO will be equal to L. So our final formula where VO by UO was there we will substitute instead of that as L by F4. So in this equation, that is equation number 4 and 5, you can make the modifications. That is M is equal to, instead of VO, what you have is L. So we will write VO as L. UO is nothing but F4. So we will write it as F4 into the same formula for eye lens, 1 plus D by FE, when the magnification is for least distance of distinct vision. If it is at infinity, the same formula is L by F4 into D by FE. In this video, we covered the topics such as the working of compound microscope and its magnifications in various settings. Hope you found this video very useful.